Okay, we'll pick up where we left off last time and take a look at figuring out the future value of a series of lump sum payments. So as an example, if we were investing money over a period of time, a series of even investments, we could see what that future value is going to grow to. So I don't want to really spend much time with the formula. You can take a look at that and think through it. Again, I want to be much more focused on figuring out the computations with Excel or a financial calculator, but we can do it longhand, and we'll look at that real quick. Let's look at an example here. Your bond portfolio is going to return $40,000 for each of the next 3 years, and then it's going to return $1,090,000 at the end of the fourth year. Assume a discount rate of 6.5%. The question, I guess, is not written here, but what is the future value of this portfolio going to be at the end of the fourth year? So we can figure out this in a series, right? We just look at each lump sum payment, break those out individually, and see what the future value is going to be, add those all up. So the first payment, the first $40,000 that we're going to receive 1 year from now, is going to grow 3 years at 6.5%, and so that's this first term here. The second payment will grow 2 years. The third payment will grow 1 year, and that very last payment, the $1,090,000 that happens at the end of the fourth year, that's going to be the future value of that cash flow, because it will have no time to grow, no time to compound. So we raise that to the 0th power. Anything to the 0th power is 1, so we're just going to get that amount right there. If we add up all these pieces, we get 1,226,287. So in Excel, there's not a simple formula for this. We're still going to be finding the future value, but in terms of computations, we can think of this as finding the future value of an NPV, of a net present value, or we could just set up a table and figure out the future value of each of the cash flows and add them all up. So we'll go to Excel here in a second and look at that. Alternatively, in a financial calculator, especially with a TI BA2+, there is a function on that thing called the net future value. And so we can stick in the inputs and then compute the net future value and get the answer really easily. So let's take a look at each of these in turn. So let's go to Excel and take a look at the calculation. Now the way I've set it up over here is with each of the 4 cash flows, I've spelled those out. I can find the future value of those, and a really simple way of figuring out the future value of all that is to just take the net present value, that would be the value at time period 0, and then just grow that 4 years. So if we compound that at 6.5% for 4 years, which is what this formula is doing, it's taking that net present value as the investment, growing it 4 years at 6.5%, I would get the 1,226,000. Alternatively, I could kind of do what we did with the formula approach and just figure out the future value of each of these cash flows individually. So let's take a look at how we would do that. So if I multiply this times 1.065 raised to the, in this case it's going to be the 4 minus 1 power, so I'm raising it 3 to the 3rd power, and that's because that cash flow is going to compound 3 years. So that's why I'm setting up my formula in the, oops, I shouldn't have hard-coded the 1. I should refer to this cell, and now I can just copy that formula down. So that's going to compound 3 years at 6.5%. If I copy this one down and then take a look at it, it's going to compound 2 years at 6.5%. And then if I drag that on down, we got this one compounding 1 year, this one is compounding 0 years, so it's going to be equal to itself. And then the net future value is just going to be the sum of each of these 4 pieces. And if I format that, I'll get the exact same answer, 1,226,287. So that is net future value of a series of lump sum payments. Let's move on and take a look at annuities. An annuity is simply a series of even cash flows that occur at even intervals or regular intervals for a specified period of time. So for instance, if you were making a payment on your car, $250 every month for the next 6 years, that would be an example of an annuity. The present value of an annuity is given by this formula here, where the cash flow A occurs regularly for n periods, and there's a periodic discount rate of R. So we've got this nice formula here. Let's use an example. What's the present value of $376.26 paid every month for 72 months? if we've got an annual interest rate of 4.95%. So again, we need to do some adjustments here to go from the annual interest rate to a periodic interest rate or a periodic discount rate. So we need to tweak the formula down here. We need to turn R from an annual rate to a periodic rate. The periods in this case are months. So let's look at that. We got 376.26 for the A, 1 minus 1 over 1 plus the periodic rate raised to the number of periods. So I've adjusted the 4.95. I divide that by 12, and I would get this 0.004125. I plug all that stuff in and get an answer of 23,396.71. So this might be an example of I'm borrowing 23,000 and change to buy my new car, and I've got a 4.95% APR from my credit union. I'm going to pay this off over 6 years. My monthly payments would be $376.26. So we can kind of go backwards and forwards. In this case, we're using the monthly payment to figure out how much we borrowed, and we can double check the dealership's math. Let's go to Excel. Well, let's go to the next slide here. So this is how we can do it in Excel. There's the PV function. We can now use the periodic payment portion of the function, and we're going to put that in as a negative number because we're paying that amount each month. So let's look at what I did here. The periodic rate, again, I mentioned I'm taking the 4.95% annual rate. I'm dividing that by 12 to get to the periodic rate, the monthly rate. The next input is the number of periods. There's 72 of those. The periodic payment is a negative 376.26 because I'm making that payment every month. So I don't need the lump sum. There's not any payment that's going to be happening at the end of all this. And the type, I can ignore that as well. So those three inputs are sufficient, and I get the same answer, 23,396.71. With a financial calculator, I can solve for PV with the following inputs: N, I, payments, and the future value. I just realized that I didn't do the cash flow for this net future value on the financial calculator. Let me go back and do that real quick, and then we'll swing around and take a look at the annuities with both of these. So figuring out the net future value for a series of lump sums, I'm again going to be using the cash flow register. So I'm going to click there, and I'm going to go ahead and clear out, make sure I got the register cleared. So I should be, yeah, there's nothing in for cash flow 1. So my cash flows are 40,000 for the first 3 years, and then 1,090. So let's go ahead and put those in. Cash flow 0 is nothing. Cash flow 1, 40,000. I hit enter. The frequency, there's 3 of those. And then the next cash flow is 1,090. That's going to happen once, and then I'm done. I'm going to hit the net present value, but we're going to scroll to the NFV, the net future value function. My discount rate is 6.5, so I'll hit enter, and I'm going to move past NPV to NFV, hit compute, and again you can see I get the same answer, 1,226,287. So that's how you do it with a financial calculator. Now let's move on to looking at annuities in Excel, and I'll scroll down here. We're looking at present values. So I could hard code those entries in, the different pieces, the 4.95% annual rate, divide that by 12 to get a monthly rate. 6 years in this case, I could multiply that 6 years times 12 months per year to get 72 periods, and then the payment, negative 376.26. Alternatively, I could spell things out really clearly. This is kind of nice etiquette for doing stuff in Excel. I've got my future value, which is nothing, the number of periods, the periodic rate, and here I showed the calculation within that cell. So 4.95% divided by 12, and then the payment. So here I just refer to each of the cells, get the same answer, 23,396.71. Very straightforward. In Excel, in the financial calculator, I've got my time value money inputs here. Let's go ahead and just clear all these things out. Now I've got 72 as the input in for the number of periods. My interest rate is going to be 4.95 divided by 12. It equals, and then hit the I to put that in. The present value, is what we're solving for. The payment is $376.26, and we want to put a negative sign there for the payment. No future value. We want to go ahead and stick that in. Hit the present value and compute. Present value, sorry. And $23,396.71. So we're getting the same results as we did for Excel, for it by hand, and then in the calculator. So we're going to pause here. We'll pick it back up in the slideshow. We'll look at the future value of annuities, and I'll see you in the next video.